Okay, let's get started. So as I just said before, my name's Phil. I'm from Massons Healthcare. I'm one of our clinical and technical educators in business development. And it's given me great pleasure to welcome Jan from Invent Medical today. And so
Hi, thank you for having me.
Jan will be running the session basically today, and I'll be running the bits and pieces in the background, hopefully. So as I say, if everyone can keep their microphones muted, that would be fantastic. We will make this session live as a recorded webinar. So just to let everyone know, we are recording. So if you could keep microphones muted, cameras off, that will make it a little bit smoother. So to introduce Jan from Invent Medical, I'd like to just let you give a little bit of a bio and a bit of background on Jan. So Jan's worked in the O&P field for 9 years. And is responsible for partnerships and business development at Invent Medical. He's a company that which is a company that he co-founded.
One down here. I'm just going to clean up. Is it going to be a huge distraction with her there? Is it going to be?
Someone's got their microphone there. I'll just try and mute that one. So as I say, Jan co-founded Invent Medical, and Invent Medical is a leader in 3D printing in the orthotics and prosthetics world. Serving 40 customers, 40 countries over 5 continents. The mission of Invent Medical was to develop a generation of orthotics and prosthetic devices that improve function, comfort, and aesthetics while making it easy and safe for clinics to adopt 3D printing and digital workflows today. So as I say, it gives me great pleasure to introduce Jan. I'm going to hand over to Jan, who will do a share screen and who has a presentation for us. At the top of your screen, you will see a chat box. In there, by all means, please put any questions and we will answer those either as we go, if it's appropriate, or probably more likely towards the end. And we can go from there. So Jan, thank you so much for joining us, and please take it away.
Yeah, thank you for having me. It's great to be here and talk about our approach to 3D printing in O&P and our devices. First of all, a little bit about us, and Phil, you did a great job covering who we are. We started in 1991 in the O&P business, so we have more than 30 years of experience, and we are a family business. So actually the company was founded by my dad and uncle. And the company started as the traditional CFAB, with plaster and traditional conservative processes, as well as we started our own patient care facility where we see patients for all orthotic and prosthetic applications, be it helmets, AFOs, SMOs, foot orthotics, prosthetics, and we treat about 10,000 patients a year just in our own facility. So really our motivation to start using 3D printing and develop new devices with 3D printing was motivated and inspired by working with our own patients. Over the time, we moved to start using CAD/CAM, milling, and 3D scanning. And the benefit of utilizing CAD/CAM was definitely achieving more accuracy, more consistency, repeatability. It's a much cleaner process, and we have a partial digital history of the device. The maybe drawback or limitation of CAD/CAM is that we are not really reducing the amount of steps. Instead of plaster, we're still producing the positive model with milling and carving, and then the actual fabrication of the device is still the same. So while this is a partial process innovation, it's not the product innovation. So it was just the next step, but not the final step for us. Moreover, the CAD/CAM, another CAD/CAM limitation is high initial investment. There's difficult CAD software to be learned, so that comes with a long learning curve. And even though we invested a lot of resources into this technology, only a handful of our practitioners was able to pick up using with the CAD software. So then we moved to 3D printing in 2010. So we actually have more than 14 years of experience in 3D printing. And the goal was to improve quality of our devices and basically to break the limitation of traditional fabrication. So we definitely felt limited of what we can do with plastic draping and drilling, riveting, and we wanted to step it up. So over the time, we actually bought and owned more than 25 printers of all kinds of technologies: FDM, SLA, SLS, and yeah, the 3D printing is just a common name for so many, so different technologies. And we were actually the first adoption of HP in OMP, and that really was revolutionary for us because HP allowed us to increase productivity and actually materialize our designs, that we had in our heads. So this is just some selected printers that we worked over time, and some of them we still do and have in our facility. So it was definitely a journey. It's not a straightforward process, and we did a lot of trial and error over the years. And right now, we fully transitioned from traditional and CAD/CAM processes to 3D printing and scan-to-print process. So even at our patient care facility, 95% of our devices are now produced by 3D printing and the fully digital workflow. Moreover, we treat or serve tens of thousands patients annually all over the world. So we work with more than 700 customers in 40 countries on 5 continents, and our team is more than 80 people spanning not only orthotists and prosthetists, but also design specialists, software engineers, mechanical engineers, and other specialties. So here's just a map, and we actually serve this demand from 3 offices. So we are headquartered in Czech Republic, but we also have offices in Germany and USA. And we have 8 manufacturing sites on 4 continents to make sure that the production is always made locally. And while we now fabricate for Australia and New Zealand in Singapore, the plan is in the next few months to transition the fabrication to Australia with a partnership with Massons. We focus on a wide range of products spanning from foot orthotics, pediatric AFO and SMO, prosthetic below knee socket, soon also the above knee, cranial remolding orthosis, post-op cranial orthosis, and the protective orthosis, and also a face mask. And so we are able to serve anybody from kids to professional athletes. And our devices were used at Olympic Games and at major leagues internationally. So why to adopt 3D printing? It's not a new technology, not even in a healthcare. So in the medical field, more than 400,000 custom-made medical devices are 3D printed every day. So it's definitely a technology ready for the prime time, and it actually has a mainstream use in orthodontics, dental prosthetics, hearing aids, and orthopedics. And why we like so much this technology is that it brings the design freedom. We are able to create new designs that were before impossible, and now they're a reality, and we can add value through breaking limitations of the traditional fab. So the goal is to create a new generation of devices that improve comfort, fit, function, aesthetics, consistency of the outcomes, and give our customers a competitive advantage. And there's a study out there saying just in a few years, 1 in 3 custom-made OMP products will be 3D printed, and we definitely see a wild adoption and wild transition happening right now, so it might be even more. And please bear in mind, 3D printing is just a tool. It can produce great or terrible devices. It all comes down to design, process, and then your printer, material, post-processing, settings. But really, the design is the difference. You can have the same printer, the same process, the same settings, and the design can make or break the device. And that's what we focus on. I'd like to show you a couple of examples of how 3D printing is being currently utilized internationally, successfully in a daily practice, and which devices you can start with even today. So one of the best examples is the flexible SMO PyroFlex. It's the least obtrusive pediatric SMO, and it's setting the new gold standard in low-tone pronation treatment, usually in patients from 1 to 5, 6 years old, with maximum 75 pounds weight. So this device is printed on HP with the TPU material, and the main benefit is it's so flexible, thin. It provides this overall compression. It has the soft heel with the, offering the proprioceptive feedback while maintaining the ML stability. And there's integrated dorsal wrap, so there's no chip to lose. And physiotherapists, orthotists, and parents and patients just love this device. It's soft where it needs to be, such as around trim lines, and gives you enough support in the ML. So you can order this device either by a scan, but more people do it through measurements. So we take 10 measurements that you can enter into our interactive app, which basically is a real-time measurements form, which automatically validates your input. And that's it. So basically ordering can take as short as 2 minutes. And we are taking also the width at calcaneus in simulated weight bearing, which ensures we have this very intimate, great fit. And the device has a great calcaneus capture, which is again improving the outcomes. You're able to select type of strap, from being one strap, Y strap, two straps, the strap position, lateral, medial. It's automatically pre-selected for you, but for us, it's important to keep your control over the device. So while we ensure the device is functional and durable and safe, and we give you full warranty, you still have so many design options and control over the final device. Here's a case study. So these are two identical twin 4-year-old boys, and they have hypotonia and severe pronation. So they tried orthopedic shoes and traditional SMOs, and nothing really did the trick. So they have a very bony leg and quite severe pronation. And moreover, their mom is a pediatric PT. So here's the before state. And after, the immediate result is significant improvement with the PyroFlex SMO. So we were able to achieve improved alignment, stability, function, comfort. We reduced the skin irritation. Mom was completely thrilled. And even though it's a very difficult anatomy, bony and quite specific, we were able to make it by measurements, and it fit like a glove. Here's words from one of our other customers using PyroFlex, and they just love the calcaneal control. They think it's incredible. They're thinking it's setting the new standard, and they especially love that they fit amazingly well. They're super low profile, They love the varied flexibility throughout the device, and they say patients, parents, and physical therapists love them. Moving on to the rest of the Piro product line, which is the other SMO and AFO devices. So right now we are focusing only on pediatric patients up to 130 pounds and maximum foot length 10 inches. And we're able to treat patients with low tone pronation, high tone pronation and supination, toe walking, knee hyperextension, crouching, and also it can be used for non-ambulatory patients. The frequent question is, what is the limitation of a 3D printed device? Can you use it with CP kits? Can you use it with when there's spasticity? For toe walkers, the answer is yes. If you can use a thermoplastic traditional SMO or AFO, the 3D printed device can be used. And we offer you a warranty on that. We actually ran trial comparison for more than a year and a half at our patient care facility. So what we did is we fit every patient with two pairs. One was made traditionally through CAD/CAM and traditional fabrication. One was made through 3D printing as Piro. And we left, parents and kids with both pairs. And next time we saw them in a couple of months, we immediately saw which pair they came in to the facility, and 95% plus came in with their Piros on their feet, and they preferred Piro, the 3D printed version. And we asked parents, why is that so? And they mentioned 4 topics that were pretty much the same for everybody: improved comfort, significantly improved fit in the shoes, better aesthetics, the kid just accepted the device more, and improved gait. And I think that stems mainly from being able to go down the shoe size. So, and they said they didn't even know where the pair of traditional AFOs was. They just lost it after a few days. So main benefits were pretty much that. It's light, it's super thin, and it's a unique design, that's breathable and improving comfort. With SMOs, we are able to offer 3 types: flex, which I already mentioned, then fusion, and active. In AFOs, we have the dynamic, control, block, night, and static. So let me show you a little bit closer the individual types. The Piro Fusion, now we are actually at the 2nd generation. Recently, we launched this update, which further improves the standard Fusion. And this is a combination of 2 materials. What you see in blue is the polyamide. What you see in black is TPU. So we're able to offer even more support, more correction than Piro Flex, and serve larger kids while maintaining comfort. So all the benefits of Piro Flex are still maintained in this device. And it comes in 4 starting configurations: standard, pronation, supination, toe walking, which again, you can modify with so many parameters. So either you can have a more hands-off mode where you leave it up to us, or you can be very specific about your design. Another is Piro Active, which offers even more support, more control for even more larger kids, and it's a more rigid device. And it comes in standard, extended version, and toe walking version. Then moving on to AFOs, we have the Piro Control, which is the solid AFO with 2 different trimline styles. And you can always select either the inner boot or without the inner boot. Then we have the Piro Dynamic, which is the articulated AFO, which comes either with the PF stop or free range of motion version. And with the PF stop included in price, you get 4 different sizes of the PF stopper. So you can easily change your plantar flexion angle. With our articulated AFO, you can select from 3 kinds of joints. There's a pivot from Launchpad, Tamarack, and Tamarack Dorsiflex Assist. Then we have the Piro Block, which is a ground reaction AFO, especially suitable for kids with strong crouching. And this device is unbelievably durable and stiff. So, even a couple of years ago, we couldn't imagine that we could get such outcome from a 3D printed plastic device. And Piro Static is, again, a solid AFO, mainly for non-ambulatory use. And the difference to Piro Control is that it includes the front shield. So that's the front shield is made from TPU. It's semi-flexible to improve the control over the leg while maintaining comfort. The new type we introduced is Piro Night. Again, non-ambulatory use, night stretching, articulated orthosis with 2 straps that are adjustable. A new upcoming type that we will release later this year is the Piro Spring, and we are so excited about this one. So it features a 3D printed strut, and this makes it the most adjustable 3D printed orthosis. So the strut comes in different flexibilities, different angles to manipulate the in-towing, out-towing, changing the dorsiflexion angle. So there's just so much adjustability you're gaining with this device, and you can seamlessly exchange the strut and tune the device even with the patient at your facility in a few minutes. With every Piro type, you are in full control over the foot plate flexibility. So you can select from 5 different flexibilities, and all our customers get this flexibility sample book, so you can actually feel it, what's the difference between semi-flexible and semi-rigid. So you get to test it on your sample book and select the right flexibility. Also, Piro is as custom as it gets. So every single device has over 100 different thicknesses throughout the device, to make sure it's durable, it's optimized for every single patient, and based on anatomy, weight, activity level, gait deviation, and so many more parameters. There's custom thickness and design for every single patient. So even if you upload 2 identical scans, but with a patient with different gait deviation or different weight and activity level, you would get 2 slightly different devices. So the process is you're using our app either to enter measurements or take 3D scans. And the measurements, the new feature is you can order by measurements, even the AFOs. For scanning, we are able to work with integrated iPhone scanning, structure scanner on the iPad, or the white light scanners. While the first 2 options are fine to trial the device, it's not really suitable for accurate long-term use, especially in volume. When you're dealing with volume, it definitely makes sense to invest into a white light scanner, that can be as cheap as $1,000, and the results are significantly improved. So here's just a quick example of iPhone scanning. You would scan the cast directly and just tell us what's the thickness of the cast to save you the time, so you don't have to produce the plaster positive. You can, we are able to work with that too, but you don't need to. So we want to give you a lot of freedom in the input data. You can upload your modified CAD model, unmodified positive model. You can scan the positive model, you can scan the negative, you can scan the cast. So there's a variety of input data we're able to work with. Here's an example of working with the Einstar scanner, which gives us better results than the iPhone or the structure scanner, while the cost is being very similar. So in the app, that's your main contact with us, and it can either be a desktop on your computer or on your iPhone. And that's where you select all the types, colors, and design modifications. So of course, once you upload the scan, we are still able to manipulate it in the way you need. So to do, some corrections of the dorsiflexion, planar flexion, to set it in the correct SVA angle, to correct the hind foot to vertical, and all the basic corrections. Of course, you should scan the cast or the patient in the foot position or leg position as close, that's as close to your desired position. The more changes we do in the software, the more we are potentially, lowering the quality of the fit. And when you select, one of the options, you always get a visual preview of what that means. And especially kids, they love the customization, to select the color of the strap, of the orthosis shell, of the padding, and to select the symbol that's printed on the device. So, it's little things, but sometimes for the kids, that can mean a word. And we definitely want to make the treatment as comfortable and as easy for those kids as possible. So we just want to make something nice for them through this customization. 3D printed materials may be slightly more difficult to adjust than your traditional materials, but we are working with so much more accuracy. So usually you do not need to adjust the orthosis. If you need, all materials that we use are thermoformable. So do not use a torch, use a heat gun, and you will need to be slightly more patient with the process, but you can thermoform the materials and push in or push out. You can grind the material as well, especially around trim lines. They're actually made for that, so they're thinner around the edges, so it's easier to grind. And even the wire we have, for chafes, to make sure they're very low profile, they are easily serviceable and replaceable. So you just need a screwdriver to, take it out and place in the new ones. And even though it's so easy, it's a very durable connection. So there's no chance that accidentally this would fall off. It clicks inside. And the durability of this wire is extremely high. So the failure rate is about 2 in 1,000. So there's a very low chance you will need to ever replace it. But this just shows, how we really thought about all little details to make it easy for you to work with our devices. And the TPU material can be even cut with scissors and then ground a little bit to make it smooth. So that's an easy material to work with. Some feedback from our customers. For Dave from New Beginnings in Rhode Island, USA, he said he's been in the OMP for more than 30 years, but Pyrodynamic was probably the nicest pair of articulated AFOs that he's ever fit. And the PT he works with, she was so impressed that she immediately wanted the sample and recommended to all her patients. Here's a Pyro block that we did for Macy OMP, and again in USA. And they chose a really difficult case that we were basically the last resort, and they loved that they got incredible results. The fit was awesome. They loved the correction and support they achieved, and they were able to go down a shoe size. This is Baylor College of Medicine, which is now Ottobock Patient Care Facility in Houston, Texas. And they exactly named, what they like about the device. More lightweight and breathable, able to don them independently for the patient. It's better fit within the shoes and allow them not to go up a shoe size. For us, what's especially critical is quality assurance. There is no shortcut to get to a quality device, and it took us years and years of work and really grinding and sweating, and design needs to follow the function. Every detail needs to be deliberate, and we always want to go beyond what's trendy, what's hype, what's eye candy, and just drill down to the function, to the durability, safety, comfort, and what really makes sense. So for example, here are some of our rejected Pyro designs from 2017, from 7 years ago. And sometimes you can see similar things on LinkedIn, but when you use it for 20 patients, for 30 patients, you start seeing the pattern why it's not gonna work well, and then you do iteration by another iteration to get to the right design. So this orthosis, even though it looks cool, we never ended up doing it because it just didn't make sense. Another examples of the rejected designs. So, you can make it look interesting and beautiful, but always the function is the number one. And you definitely can see that some of the elements we kept while other we refined over those years. On average, every product line we do took us, to be where we are now, 500 to 1,000 different designs. Iteration means it's a design we created, we printed, we tested through several, steps, be it mechanical testing or testing with the patients, and then created a new version based on what we learned. So it's a lot of work, and it also took us a lot of time. So on average, development of every single product line took us 5 to 10 years. And we never stop. We offer constant improvements. Every single week, we do some small update, usually behind the scenes, to make sure that we're constantly improving fit, function, comfort, and your design options. So our goal is to make sure that with us, you always have the most advanced device on the market. And there's a lot of mechanical tests involved, computational analysis. We test all the devices first for months with our own patients in-house. We have our own material testing, and we drill down, to the core settings of the technology. And that's why we're able to give you a full warranty on any design and fabrication issues. So we have constantly evolving in-house testing lab to make sure that our devices are, perfect for you and for your patients. Then, every single device we do, we have an inspection team, which consists of clinicians and technicians that check your input data and check the design before printing to make sure the device is right. So the summary for the Puro, it's the #1 sold 3D printed AFO and SMO globally, and it has years of been proven on the market and being reliable. And right now, we serve tens of thousands of patients, and it's constantly evolving. Moving on to our helmet, Tele. This is, for a change, the #1 sold 3D printed cranial orthosis globally. And the journey there started actually in 2014. So it's a very optimized and mature device. We treated more than 30,000 patients with our helmets, and it's available globally on more than 700 locations, and it's a patented solution. We run our own cranial focused facility. So we ourselves see about 1,000 patients a year in our facility. So this is really where we got all the insight, to design the device. We really designed it first for our own patients. So the main benefits are, we wanted to redesign the traditional helmet that is too bulky, too much sweating. It takes a long time to adjust and train. It's very heavy and has this obtrusive strap. So with Tele, we integrated the closure system. We added perforations. We made it 2 layers to make sure it's very breathable and addresses all of those issues. It weighs less. It's comfortable for being thin. And especially the game-changing is reduced skin issues, up to 90% less, especially in hot and humid climates. And just because there's so much less sweating in this helmet. And we're able to provide controlled results and improved compliance with this device. So the indication is the same as for other cranial helmets. The age to start is, or age for treatment is 3 to 18 months. Ideal age is to start is from 4 to 7 months old. And we're able to treat from mild to very severe deformities. On average, the treatment duration is about 4 months. And in more than 99% of cases, you need only 1 helmet per treatment. And we also offer the post-op version of the helmet. For 3D scanning, we're not accepting with helmet the structure scanner, the mobile scanning, and the star scanner. You need to use a wide light scanner from a list of recommended devices, such as Shine Einscan or a body scan from TechMed. The scanning with a handheld device has gone a long way. So right now, with our training, you're able to get a perfect scan in about 30 seconds, even if the baby is moving a lot. So in this example, in a moment, you'll see that it will lose tracking for a bit. But with this scanner, what's great is if you lose it, you just go a little bit back to connect it, and continue and finish scanning in pretty much no time. So we really like the Einscan for the cranial scanning. What is new and unique to Tele is a groundbreaking 2-in-1 feature, which means there is the replaceable inner posterior layer. So it basically gives you the ability and the features of 2 orthoses in one. So it's a combination of the most improvement growth within a single device, while ensuring great fit and stability throughout the treatment. So you start with this first layer, which is good for about a few weeks, about 10 millimeters of growth. And it immediately fixes the symmetry a lot. Then you replace it for a deeper second stage, for the final layer, which allows further growth in the helmet, allowing even more improvement. And we did this because otherwise with 3D printed helmets, you have a lot of rotation. But with this 2-in-1 feature, that's solved, and we're also able to get much more improvement. And it's very easy to swap these layers, so they're securely clicked inside, but you just need a screwdriver to get it out and place in the second layer, which you get for every helmet you order. Ordering is simple. You just use our online platform to upload the 3D scan, enter the date of birth, some other clinical information, and you get back the orthosis to be fit in 2 weeks. You're able to select the colors, and also parents can choose their text to be printed on the forehead in different kinds of fonts, and also the symbol for the site as well, you know, making it a little bit more fun and acceptable. We're also able to integrate the ortho-time sensor, which is, I believe, fantastic to measure the wearing time and fight the non-compliance. So this sensor tells you how many hours each day was the helmet worn. Adjustments are much easier, so this helmet saves you about 50% of your clinical time or even more. You get a set of pads that you glue inside the helmet to ensure stability. And there are predefined positions on cheeks and mastoids. It's even printed or marked on the padding for every single patient custom, where the position of those pads should be if you need to use any pads. Of course, you can still grind the helmet too, but it's not that you would have to do it usually, only in the neck area, where we start with a thicker wedge. Included in Tele is this powerful treatment progress app. So that gives you ability to upload scan at every single checkup or whenever you decide to, and you see all the numbers, the 2D visualization and comparison, the 3D comparison too, and the heat map and all the information. So that's a powerful tool for the treatment evaluation. With one click, you're able to generate these beautiful visual reports for parents to keep them motivated throughout the treatment and informed. And we have also a mobile app in this first phase. You have, it's not, the reports are not included, but there's many useful information and articles for parents. And for us, it's important to have this constant systematic innovation. So we have in-house development team, about 25 R&D specialists, and every year we commit to spend significant resources to make sure we are moving ahead. So this year it's about $2 million. Results are beautiful with Tele. So you are able to get even significant improvements, significant growth in a single helmet. With every orthosis you receive, we are transparent about the modification we do for you. So within 24 hours, you are able to access this modification report for every single device on your online portal. And so here's one case for plagiocephaly patient where we got to norm, improving CVAI by 9%. Here's a brachycephaly patient that we improved the proportion by more than 12%, and CVAI just fine-tuned by 2% to get in a nice visual outcome. And on the webpage, you can read many stories from parents when you go to teletop.com. To get started with any of our devices, you just need to contact Massons with your contact information. You'll get access to the free online training, which can take as short as 20 minutes for the Piro Flex or as long as few hours for tele training. And once you finish the training, you create your online account. If you don't have a 3D scanner, you need to get one, and you can start trials with your patients, and we make sure they're risk-free. So if you don't like it, you send the device back, we give you money back. Just, Ogo prosthetic socket. I just want to devote the last 2 minutes here. With prosthetics, we are able, through custom thickness throughout the device, through combining two materials, to achieve something that most of the patients wearing Ogo refer to as the most comfortable prosthetic socket they ever used. So the main reason for that is the proximal area is more flexible than it would be with laminated sockets. So it feels like more bio-responsive to those patients, and they really love this feel. We're also able to integrate your alignment right inside the distal end. So it comes with the inbuilt final alignment. The distal end is optimized, so it's actually much more lightweight than the traditional distal end would be. And the weight is actually distributed more evenly throughout the device. So that also makes it, even though it's not more lightweight than the laminated socket, it's about the same, the patients perceive it as more lightweight. And we integrate soft silicone pads inside on the sensitive areas, to make sure there's no pressure, that it's, again, self-adjustable. And we have this unique patented soft, comfortable, flexible brim that can be stiffer in the ML while being more flexible in the AP. So the brim is another reason, why patients like it so much, and it's also improving their liner, durability and lifetime. So this is just what the brim feels like, and the whole device is made to be just so much more comfortable. We're able to integrate different kinds of suspension mechanisms, so locks, valves, and hybrids from Oster, Autobag, Bulldog, Coyote, Willowwood. So there's so many different, suspensions that you can choose from. And to give you a brief overview, we have the standard socket, which is a traditional socket, comfort, which is with the flexible brim, and control, which is volume adjustable. And coming soon is also the diagnostic socket that you can either receive or print in-house. So especially the volume adjustable socket, I think is interesting. You can either receive it with a soft brim or with the full flexible inner. So this could be used also for the elevated vacuum. So we're seeing a lot of interest in this device, and there's a reel that you can just turn, to change the inner volume, to make the volume changes throughout the day. So just the summary of benefits is the most comfortable socket per the reports of the patients. The proximal area flexibility is being mentioned very often. The soft brim, soft inner pads, built-in alignment, the socket being lightweight and durable. It's safe. It's tested for 1,100 pounds. It's volume adjustable version, and we're receiving a lot of positive feedback. So please make sure to talk to us or Massons if you're interested in learning more about the Ogo prosthetic socket. And if we have any questions, I'll be happy to answer them.
Thank you so much, Jan. That was fantastic. Just to to change a couple of those numbers into our Australian metric numbers. So Piero is 65 kilos and 25 centimeter foot length. And the Orgo socket rated to 125 kilos, just for those that are playing at home. A couple of other things that I'd like to mention. There haven't been any questions come through, Jan, but I think you've probably covered a huge amount of information there for everyone. A couple of things that I would like to mention is the scanning. So here at Massons, we have a number of options for scanning. We have our Massons app, which is using your iPhone. You also can order structure scanner through us to go onto your iPads. We also have recently begun distributing for Shining. So we have the Iron Star, which Jan was talking about, as well as the Iron Scan. We'll also have those at our booth at AOPA. And of course, we also have our Omega scanner, which is the body scan. So similar to TechMed, so the same scanner as that as well. So please feel free to reach out to us about any of your scanning options as well to help bring you in and on board with Invent Medical, as well as all the other digital workflow processes that are available now in OMP, which is really exciting. Sean has just put a question through for us. So the adult AFO is still in development, question mark? Any time frames as to when that will start to be an offering?
Yeah, that's a great question. So there's not an official timeline yet, but we will use everything we learned in the pediatric AFO, and especially with the spring, an articulated AFO too. So we're working on the pediatric AFO. It's giving us a groundwork for the adults. So once we get the spring right and fine tune that, that will be a great start for the adult line.
Thanks, Jan. Jan, just another one, just in terms of the Tali, Tali Protect. Is there any way of doing a Tali Protect without having a scan? Are you able to do a Tali Protect with measurements only? We had a question about a Tali Protect in terms of being able to take, fit someone without being able to have a cast taken of them just because they were moving around so much and things. So is there potential to take measurements?
There is not, because it's fully custom. But with Tele Protect, we don't have so strict, like strictly defined scanners. So even if you scan with iPhone or structure scanner, that's acceptable for the Tele Protect. But that definitely gives us much better information that the measurements would in terms of cranials. I see there's also a question about Tele being able to be used for post-surgical patients. We do that. We have the Tele post-op, which is very similar to Tele, and we're able to do that for post-surgical patients if they were, if the surgery was the strip craniectomy. So if it's the traditional remolding surgery, we don't do that. But if it's the endoscopy strip craniectomy, then it was actually what we started with. Even before we started to do Tele for positional deformities, we had this post-op version. So definitely post-op is available.
And Michael's just asked in terms of adult AFOs, whether it's a strength of materials or is it the design algorithm that's the development that's happening there, the barrier to being able to move into adults?
Yeah, I would say partially both, and both can be solved. But the number one obstacle is with 3D printing with HP, and I honestly believe only HP is able to handle that task. You pay per volume. If you print pediatric orthosis or adult orthosis, the price varies. And if the foot length is double or the height of the orthosis is double, you basically pay at least the double or even more. So with the task of developing adult AFOs, you also need to do it in a way that reimbursement systems would pay for. So, let's say a regular solid AFO, if you print it in one piece, it may not even fit into the printer. And if it does, it's going to be extremely expensive. So we know how to solve it, but there's a lot of development, involved. So that's the main challenge. And with kits, there's so much potential, so much value we're adding. So we want to make, and it's making so much difference, especially for these little kids. So we want to make sure that we address, their needs, and then we move to adults. Wayne is asking if there are companies printing adult AFOs. I think there could be some, but yeah, there's definitely higher chance of breakage but yeah, definitely you can explore that. We will do adult AFOs too, for sure. But we always want to take maybe a little bit slower but very responsible approach to development, and making sure you're not stuck with a device that would fail for your patient.
I think that probably leads into the next question there, Jan, about warranties on the 3D printed lower limb orthotics in case there is a break.
Yeah, so pediatric lower limb AFO, SMO, it's worn usually for 6 to 12 months. And that's why we give you warranty for up to 1 year or on all design and fabrication issues. So if it would break in normal use, we replace free of charge the device. If for some reason, the parents or the PT didn't want that, we give you money back. So we feel very confident in offering you this warranty, and not many companies do in 3D printing. So we want to make it absolutely safe and risk-free for you to transition into 3D printing. We had a case that they drove over the device with their car. That's not included in the warranty. There's, I also like to be very transparent. There may be some color wear that's not included unless, it's very extensive. That's where the, I would say, technology of post-processing the 3D printed parts is today. There is a color 3D printer, but that has some other limitations that for us were much more severe than the color, a little bit scratching off. So there's different approaches, but yeah, for any cracks or breaks caused by regular use, it's covered.
Thanks, Jan. And I think I can just sort of add into that is that in terms of materials, so the TPU itself is black, and it comes black, and it's always black. But however, the shells, the PA11 shells on the outside, in this case, the colors come from painting them. So there are options to dye, but most Piro, especially with the Piro AFOs, they are painted. So what Jan was talking about there of it scratching, that can happen. So it is something just to be aware of. And I think, over time, the way we paint and the products that we use to coat these will get better and better, but it is still reasonably early stages. So they are very wearing friendly, but they can scratch, especially on like edges and trim lines and things. There is the potential for that color to come off, but as I say, I think that's getting better and better. So there haven't been any other questions come in. I'll just highlight a couple of things. So the way that the Invent Medical and Massons work together is that we set up our training portal for the Australian version, and there's the ordering portal as well. So if any of you have, I know a lot of you have completed training. If there are any of you who would wish to undergo the training, please reach out to Massons, either at info, or you can come directly to me, phil@massonshealthcare.com.au, and I can set you up with the ability to go into that training portal. Once you've completed that training, we then set you up with an ordering portal for the Australian market, and you can begin straight away ordering. So that's for Australia and New Zealand. So yeah, any questions, please reach out.
Yeah, my pleasure. Thank you for having me, and thank you everybody for listening in.
No worries at all. Thank you so much, guys, and we'll end the meeting there.